and welcome to the kindergarten dive in 5 for comparing and ordering numbers up to 20. We are going to see a lot of the same strategies that we used when we were comparing numbers to 10, but we're going to talk about how to utilize those strategies that we used in the past to help us with these new numbers. First task, what we are going to do is in just a moment, you are going to see a part A and a part B pop up on the screen. When you're solving for part A and part B, what I'd like for you to do is think about if you are asking these two questions to a student, jot down how many different responses you can think of that your students might tell you. It could be correct and incorrect responses as well. So go ahead and here's your part A and your part B. Go ahead and pause the video and come back when you are ready with your student responses. Before we dive into our first task, we are going to look at the progression with our best standards. We know so far in kindergarten, we have set a foundation for numbers 0 through 20. We also just finished representing learning up to the numbers up to 20 with those naughty teen numbers. So right now our focus is comparing objects from 0 to 20 in two groups using the terms less than, greater than, or equal to. We're also locating, ordering, and comparing numbers from 0 to 20, specifically using a number line as well as the comparison terms that we just talked about. The symbols do not come into play in kindergarten at all, so there's no need to try to take that on. We are simply focused on the vocabulary and the amount of objects that a number represents. You can see how this is the building block for 1st through 5th grade. When they are plotting, ordering, and comparing numbers, they start with 100, then 1,000, 10,000, 1 million, and then get into decimals and fractions. So kindergarten is really important for this branch of standards here. Part A component of our first task, thinking about the numbers that our students are already familiar with. If you asked your students to compare the numbers 9 and 5, thinking about all that you've taught them earlier in the year, and ask which number was greater and how they knew, what do you think some of their responses would be? So here are a couple that you might have come up with. 9 is greater than 5 because when I count, 9 comes after 5. That's very typical to hear from students. You also might hear 5 is less than 9 because 9 is greater than 5. And even though they're talking about how they know 5 is less, they're still bringing in that component that they understand that 9 is greater. So that's a great response as well. This one is interesting. I matched them up and saw that in the group of 9, there were leftovers, so that's how I know 9 is greater. So you can tell here that the students are using that matching strategy, maybe with some tools to compare the two numbers. These next two are a little bit more complicated. So when we look, we see 9 is greater because when I look at the two numbers on the number line, 5 is closest to 0. And then the other one, 9 is greater because I counted up with the number line 5, 6, 7, 8, 9. So with those two responses, those students would have been utilizing the number line to help them determine that 9 is greater than 5. Here in the blue, we get a little bit more complicated. So we have 9 is greater because 5 plus 4 equals 9. So 5 needs 4 more to be equal to 9. And then 9 is greater than 5 because I have to add 4 to 5 to get to 9. So thinking about what you've done with addition and subtraction, those responses from those students are having all of those strategies that you've worked on. They're starting to internalize them and use them to compare. You may not have heard as very many of those responses with the last unit with the lesser numbers, but now with this one you've had instruction on joining and separating as well as composing and decomposing. So we're leaning more towards those more complicated or deeper responses from our students. And here's one more, thinking about subtraction. I subtracted the 2 numbers and there were 4 more left over. With a 9, that's why 9 is greater. So again, students thinking about the addition and subtraction component of comparing numbers is really important. And it is a lot more difficult, but thinking about how important it is to ask our students, how do you know when a number is greater or less? Just that one question is going to elicit different responses. Though we have already worked with concrete models when we compared and ordered numbers from 0 to 10, we still need to give our students that concrete representation experiences with these greater numbers, because in all honesty, some of our students are still learning about these numbers. And it's great for the students that already have a good foundation about these numbers to go back to that concrete understanding. So you can see here is just a quick example of comparing with snap cubes. You can use unifix cubes. Here, students are comparing pepperonis onto pepperoni pizzas. And even though they're not actual manipulatives that may have come in your kit, they are pieces that students can move around and they can manipulate. So as long as students can pick something up and move it around to compare it in a way that makes sense to them, then you know that you have a concrete model because they're actually touching and moving things around. And here in this last example, you can see an example of how there are plates and cups in little pictures, and students are using 10 frames to move the tools around as well. And we want to make sure we're using, at this point, we're using double 10 frames because we are working with numbers up to 20. Here we see some examples of concrete and representational models together. So thinking about what we just saw with the students and the pepperoni pizza, if they are using those tools and moving around the tools to compare on their pizzas, the next connection that we can make is we can have those pizzas and we can have students actually drawing the pepperonis and writing the numbers. So that would be a connection of a concrete to a representational model, that direct connection, exactly what they were doing. As well as you can see the double 10 frames with the plates and the cups. That is the same thing. The students were taking the tools on the 10 frames, manipulating them around, and then after they were done comparing the numbers, then they drew their representations on the double 10 frames there. So again, in order to move our students from the concrete understanding to the representational, we want to make sure we are comparing and connecting the tools that we utilize. Speaking of concrete to representational models, we want to make sure that we are connecting our number line models, which can be very abstract for students to understand, to concrete representations. So here are just a couple of examples. We can take our tools and we can build the numbers right on top of where the numerals are represented on the number line. This will help students actually see when one number is taller than the other, then we know that one is greater. And the number that is closest to 0 is the number that is always going to be less. And so that will help students start to have that understanding if we're connecting to the concrete representation. Here are just a couple other ways that we can utilize tools with number lines. We can have little hooks and we can have students build the numbers representing that way. And then here we can have students hopping as well. That gets into a little bit more of the representational and the abstract phase versus actually using the tools with the number line. Now, thinking about comparing and ordering misconceptions. So there's a few misconceptions that we're going to talk about. If students are struggling to compare numbers using a number line, that means we definitely have to go back to the concrete and separate them onto sets. You can use mats. You can just use whiteboards that have two different sets that they can put the numbers into. And so then separating them with tools into separate sets and then allowing students to build those actual numbers on the number line will help make those connections. If you see students that are struggling with being able to compare the written numerals, we want to make sure we're comparing written numerals to modeled sets again. So if you're asking a student to compare 14 and 19 and they're struggling because they just have the numerals there, we can ask, can you draw a picture of the number 14 and the number 19? If not, then go back. Can we build the number 14 and then build the number 19 and then go from there? Last one, if students confuse the size of objects with the number of objects when comparing, then you want to make sure you're utilizing different size of things. So for example, if we have 3 chocolate bars, some students may say that 3 is greater than 7 if we're comparing chocolate bars and marbles, simply because the marbles are smaller in size. So we want to make sure we are making sure that our students don't have those misconceptions by asking them to compare different sets of items. And by supporting that, we can have them build with tools. Can you build 3? Can you build 7? Or because we're in greater numbers now, can you build 13? Can you build 17? And show how you know which is greater. All right, and remember, it's not a race to get to the abstract way of thinking. We want to make sure we are building our students' understanding by starting with a concrete, with the tools that they can actually manipulate, and then making connections to what they're doing with the tools to pictures that we're asking them to draw. And then finally using more abstract ways, such as just a number line and just numbers to compare. Our math dive in about 5 on comparing and ordering numbers to 20. I hope you join us for our next one.